Good morning, ma'am. This is Madhura Lakshman Mane from ECF, and I'm going to discuss the topic on Raman spectroscopy. Yeah, these are the contact introduction, principal strokes and anti-strokes, analyze and scattering diagram. Okay, introduction of Raman spectroscopy. A molecular spectroscopy which is observed as inelastically scattered light allows for the interrogation and identification or variabilization state of molecule. As we know, it is used for product forming and for the change state change and stresses and strain, yeah, crystal form and crystallinity. And it as a result of Raman spectroscopy provides an invaluable analytical tool for molecular fingerprints as well as monitoring changing, yeah. Then Raman spectroscopy requires little to no sample preparation and insensitivity to aqueous observation bands. This property of the Raman facilitates the measurements of solid, liquid, and the gases not only directly but also through transparent containers such as glass and plastic. Yeah, Raman spectroscopy is highly selective. Yeah, as in the complementary method of FTIR, which allows to identify and differentiate molecular and chemical species that are very similar. Yeah, and Raman spectra can be used for the material identification and uh, verification. Yeah, then okay, then next comes to principle. Yeah, a principle when a monochromatic radiation in incidence upon a sample, then this light will interact with the sample in some fashions. It may be reflected, absorbed, or scattered in some manner. Okay, it is scattered of the radiation that occurs, which give information about molecular structure. Yeah, molecular structure. And a small portion in the inelastical scattered Raman scattered composed of Stokes and anti-Stokes portion. This latter portion is what we are particularly interested in because it contains the information in which we are interested. The spectrum is used with the laser light. Hence, the peaks are measured as the shift for the laser light. Yeah, the peaks position are determined by the vibrational energies associated with the bonds in the molecule of which the sample is composed. Yeah, because of this, the spectrum uh, ends looking up similar. Yeah, ends oh, looking up similar to an IR spectrum and interpreted similar. Yeah. The bands that are Raman spectrum are those that are highly polarizable bonds, such those with alpha electrons. Yeah. Okay, then we turn to Stokes and anti-Stokes. Okay, Stokes shift is the differences in energy, wave numbers or frequency unit between these positions of this band. Maxima of this absorption and emission gets together and the same electrons transmits. It is sometimes the Stokes shifts are given in the wavelength unit, but this is less frequency unit because it depends on the absorption wavelength. Yeah, and anti-Stokes is uh, if if the emitted photon has more energy than the absorbed photon, The energy differences is called as anti-stock. The extra energy comes from the depositions of thermal photons in the crystalline lattice, cooling the crystal in the process. It's it's common pigment uh, absorbed in a infracted emitted in the visible region of the spectrum. Yeah, and it in this case the haha, it is most commonly observed in the Raman spectrometer, where it is used to determine the temperature of material. Yeah. Okay, then we move towards to Rayleigh scattering. Yeah. Rayleigh scattering is an electric polarization of the particles. The oscillation electric field of a light waves act in the charge within a particle, causing them to move at the same frequency. The particle therefore becomes a small radiation dipoles whose radiation we can see as scattering light. Here we see, and scattering of the sunlight in the earth's atmosphere cause diffuse sky radiation, which is the reason for the blue color of the daytime and the twilight sky, as well as the yellowish to reddish. Yeah, we see. Yeah, and then we move. Thank you. Thank you, ma'am.